Hi, welcome back to the channel. So in this video, we are going to see the matrices and determinants, the basics of matrices first of all. So for this, we should see that is Sir Arthur Kelly is invented the matrices and Kramer invented the determinants. Suppose if we written this in the rectangular format, which consisting of some elements like this, so we'll call this as a row and this as a column, horizontal as row and vertical as column. So here how many rows are there? So 5 3 2 is one row, 4 1 0 is another row. So two rows. Columns 5 4 is 3 1 and 2 0 are columns. So we'll call this as a 2 cross 3 matrix. If we call it as in terms of order, we'll call it as m into n order, where m is row and n is column, right? So next we'll see what is square matrix. So square matrix directly I have written like this. So it should consist of equal number of rows and columns. We'll call it as order number 3 because 3 rows and 3 columns are there. So it is m into n is 3 cross 3. So if it is like this, so it is order is 2 because 2 cross 2, 2 rows, 2 columns. Then what is diagonal matrix? So from square matrix, all these are derived from square matrix. So diagonal matrix is, look at the matrix which is square matrix, which is 3 cross 3. So square matrix with non-diagonal element 0. So here we'll call it as a diagonal elements, which is principal diagonal elements. Other than this, all the elements are 0. So it is called diagonal matrix. Basically, it should be square. Then the principal diagonal or this diagonal elements should have some values. Okay. Suppose the same diagonal values are having the same value. That is 3, 3, 3. So we'll call it a scalar matrix. So it is a square matrix with a diagonal matrix with the equal values. It is scalar matrix. If it is not equal, it is just a diagonal matrix. Right? Now, if these are having a value 1 diagonal matrix, so we'll call it as unity or identity matrix, right? Then upper triangular matrix. What is the meaning of upper triangular matrix is, look at this. Above this principal diagonal elements, all elements should be present. Below this, it is 0. So these values are 0 and above is, it is upper triangular matrix. That's why I have drawn the triangle also like this structure. So that elements should not be 0 and other than that should be 0. So lower triangular matrix means, so here this is a triangle like structure and above this the values are 0. So we'll continue with the next part, that is algebra of matrix. What is, we can add, we can subtract, we can multiply, we'll see this. First is equality of matrix. Suppose if I write 5 3 2 4, if I write ABCD, so the position of this A value is 5, B is 3, C is 2 and 4 is D. That is why we'll write it as equality of matrix. Then addition of matrix. Suppose if you write here 2 cross 2 and 2 cross 2 matrix, so 1 added with 4 is 5, 2 added with 5 is 7, 3 added with 6 is 9, 4 added with 7 is 11. So same order can be added. So suppose if it is 2 cross 2 and it is 2 cross 3, we can't add that. So keep in that mind. Next, scalar multiplication. Suppose the A value is like this, we can multiply this A matrix with 2, like 2A. So for this, multiply each element by 2. 2 into 3 is 6, 2 into minus 2 is 4, like that. Next, B is written like this. So if I write 2B, multiply each with 2B. Suppose you want to add this 2A and 2B, 2A plus 2B. So add this matrix with this matrix. What is 6 plus 2? 8. Minus 4 plus 4, 0. 2, 8 plus 6, 14. Like this you will get the result. Next, properties of matrix multiplication and scalar multiplication. So these are the basic properties. Commutative, that is A plus B is B plus A. Associative, A plus B plus C is equals to A plus B plus C. Look at the brackets, how they are put it. A plus B equal to A plus C. So where A and A, look at the position, B equal to C here. If A plus B equal to C, A is equal to C minus B. So K into A plus B equal to KA plus KB. Right? So these are the properties of matrix multiplication and scalar. Then one more very important concept is transpose of matrix. Suppose A is order m in cross n. A transpose means it is n cross m, reverse. Means rows can be, and rows and columns can be interchanged. Suppose A is like this. A transpose means Row can be written as column. Look at here. 5 2 row here. 5 2 becomes column. What is 1 3 row? What it becomes 1 3 column. Right? Next. Similarly, we can write here I transpose is nothing but I, because 1 0 I means it is identity matrix. Suppose if we write like 1 0 0 1, so transpose of this is row becomes column, row becomes column. It remains the same. I transpose is I only. Next, A double dash is A. So suppose if we write A, and what is A dash, we'll write like this. Then A dash of dash. Again we should convert this. So finally it is nothing but this. So it is A. Similarly, symmetric and skew symmetric matrices will be there. We'll elaborate this section in the next. A is a square matrix such that A transpose is A. That time we will call A is symmetric matrix. What is that? A is a square matrix, that is M cross N. A transpose is A, at that time A is symmetric. If A transpose is minus of A, then we will call skew symmetric matrix. Then matrix multiplication, a simple example. This is for the beginners. Find AB if A is like this and B is like this, right? So here we know that it is 2 cross 3 and it is 3 cross 2. We know that here 2 and here it is 2. First, here it is last. So product matrix should be 2 cross 2. Now consider whatever here and whatever here. Take the first row and first column, multiply with each element. 2 into 0 plus 3 into 8 plus 5 into 4. So the first is over. Then same set multiply with this 6 7 3. 2 into 6, 3 into 7, 5 into 3. Next, come to the second row and do with these two columns. 6 into 0, 1 into 8, 2 into 4. Next, 6 into 6, 1 into 7, 2 into 3. So start doing the multiplication and addition. You will end up with this. Okay. So you can observe what is the matrix order 2 cross 2. 2 rows, 2 columns. So that's what we told. Product matrix should be this. So this you should remember. 2 cross 3 and 3 cross 2 here for this example. First element and last element is order which is having the product matrix. Thank you. We'll see in the next video with the next update. Stay tuned to this channel for the basics of mathematics and engineering, MTech, PhD. Thank you.